Alright, this video is an instructional video about how the light is actually breaking up and hitting the earth and creating the 46th and the 22nd degree halo, as well as the double rainbow. And I'll get to that, why that is happening, and I'll bring up a video where this guy actually talks about how light is going through prism, and depending upon the distance away from the light source or from the actual division of the spectrum, you're going to get a reversal of the spectrum. And so that's exactly what's happening within the concavity of the Earth. You watch the sun dog video that I made a few months ago. You'll see over here that little white dot is the sun, and so I got this sunglass sphere covering the sun, and then a wider moon glass sphere which has negative refraction covering the moon. And we also see how I, through optics and illusion, I created the inversion of curvature, and so we have this top-sided dome. It's going to be going down to the ground like that. I picked Norway as location, and the sky gets figuratively split in two, and so we see the arrows toward the 22nd and the 46th, and then we're going to see the actual inversion in just about a second here. Visual half of the sky inverts on the curvature. Okay, there it goes. Okay, and so from ground's point of view, because of the ice crystals that are closer to Earth, it's going to pick up, it's going to create a canvas, a reflective canvas of the glass filtered light like that. And so that's why we get the 22nd over here. That's why we get the 46. That's why we get the parhelic circle. I think it's the 100-kilometer glass sphere and the ice crystals in the sky that are picking up on that. And light is polarized, so we get the actual formation of what looks like to be an octahedron. That's just a little it's just a little indication of what I've been telling you is true. And so that's what's happening, but the reversal is happening. I'm just going to go into Illustrator here and show you why that's happening. It's because it all has to do with distance. That's all it is. And so I just drew a little, let's see here. Let's get my zoom tool. Zoom out a little bit. Okay, top-down view, heaven in the center. And we have the sun. If I zoom in really close, you see that little white half circle right there. That would be the sun. Light is going out from the sides like that because of the magnetism, because of the bending of the light like that. It's done like that. That's how it works like that. That's how I tricked the heliotard. And what's happening when the sun goes out like that, also, that's, of course, we get the glass in front. That's why we get the bulge. That's why we get the stellar displacement. But anyway, we get a particular incident angle. I'm not really sure what it is. I haven't even bothered looking into it. But there's got to be a same angle in which the light is entering or leaving or passing through the glass. And both of them will create the spectrum like that. So we get the spectrum created because there's glass. It's close by, close to heaven. Okay, and so on this right side over here, you see the green line and the blue line. You have a shorter distance line for the green and longer for the blue. And so you'll notice that the green, somewhere in Earth, the sunlight's going to make a spectrum and halos, and well, both halos, 22nd and 46, are going to be created. And the red is going to be on the inside for both. So I put a little picture here indicating, showing you that 22nd degree halo, yep, the red's on the inside, and the 46, the red is on the inside like that. Okay, so that's what's going on there. But as we get further away, like toward when the sun is getting closer to the horizon, we're going to get a flip. We're going to get a reversal with the secondary rainbow. So the double rainbow is going to be seen. The moon glass sphere, the moon glass and sun planet glass. And the moon glass 46 reverses on itself. And so that's what's happening. It's just a matter of distance. This guy really helped me out here. This guy, what's his name? I'll pull up the video. Give him a little thank you. MITK 12 videos. I'll play a little bit of it.
We see the same spectrum that we started with, but with the colors now. We start with our screen close to the lens, and we see the same spectrum we saw before. Here is the light passing through the lens, and up above it we see the light that's sort of skipping the top of the lens. As we move our screen away, the colors begin to overlap until at one point we see a band of white light.
Okay, we got a convergence of the white light, but then watch this.
As we continue to move the screen further away, we see the same spectrum that we started with, but with the colors now reversed. As we move the screen in this experiment, there's nothing to cause this change of color that we're
Okay, it's right there. You get a reversal farther away. And that's why we're getting the reversal in the sun and the moon glass sphere. Evidently, the sunlight is too close to the sun-planet glass sphere for that to reverse. It needs to be, the distance of that would need to be further away for that to reverse like that. Okay? But that explains... Did you get that? Let me see if you got that. I might have to play that again. I'm not really... It's hard working on a laptop here. Let me play that again.
Experiment. There's nothing to cause this change of color that we're observing. The only thing that's changing is the overlap of the colors. So we can conclude that when we perceive this white light, what we're really seeing is a whole bunch of colors added together. Now, it turns out that you don't actually need all of these colors to trick your eyes into seeing white. If you're watching this on a TV screen or a computer screen at home, what you're seeing as white is actually a combination of red, blue, and green. But
okay, let's go
in the
back
direction
here.
that the colors were spread, the pattern was much wider than it should be based on the system geometry. Right, you see the light that's sort of skipping the top of the lens.
Okay, so he's got a negative meniscus lens in front, and it's dividing the light like that. But also, what it's doing, it's going to be converging it as he moves it further away.
The colors begin to overlap until at one point we see a band of white light.
Yep.
As we continue to move the screen further away,
yep,
we see the same spectrum that we started
so we get the reversal right there.
with, but with the colors now reversed.
Okay, so that's exactly what's happening with the 22nd and the 46th degree halo, and the reason why we get a reversal in the double rainbow. So, zoom back out and show you that. Okay, so that mystery is solved. Okay, this was kind of bothering me in the back of my mind for a while. It's like, why is that happening? Well, that explains it. Okay, kind of hard to see these lines here. Let's select them all and make them darker. Yeah. Make them a little bit thicker too. There we go. So we see, I show you how the illumination is happening from the top as the sunlight bends around like that. I showed you that in my originally in that Beetle's Concave Earth video. But that's how it's creating the different phases of the moon and then how the light is bending out like that. Okay. All right. Good. This should help you guys.